All right. So hopefully this is still a live camera. Oh, good, it is. All right, everybody. So let me show you the right way to convert from standard to vertex form. And it's easier than what I was trying to do. So that's good news. All right, I'm going to use some different colors here so it pops. Okay, so we are given this example one right here, negative 3x squared minus 6x minus 9. There it is in standard form. The first thing I want to do is make sure that coefficient of x squared is 1. So again, in this case, it's not. I have a negative 3. So I do want to go ahead and factor out the negative 3 from the whole thing. Okay, so watch how I do this. So I'm just taking this original and I'm going to factor out a negative 3. So I'd have x squared plus 2x. And then I'm going to leave myself a little bit of space right there. And so that would be a what? A plus 3. And you'll see why I leave a little space. I'm going to leave a little space on both sides of that constant. You'll see why in the next step. So far, all I've done is pull out a negative 3. So far, so good? Everybody's with me? All right, now in step 2, I still want to find my x term. I'm going to take half of it and square it, just as if I were doing completing the square. So I want half of b, and I want to square that value. So b in this case is 2, take half of it is 1, square it, I get 1. So in this case, I happen to get 1, whatever it is, there it is. I'm going to refer to it as a magic number, just so we have an easy way to reference that number. And now here's the weird thing, but it's so cool. So all I'm going to do, I'm going to recopy exactly what I had. Y equals negative 3 x squared plus 2x, leaving a little bit of space. Okay, so I'm just recopying what I had from step 1. Here's what the very interesting, this is such a cool little trick. Now, normally in completing the square, we find that magic number and we add it to both sides, right? I haven't moved any, I didn't move C to the other side though. Everything is still on the right-hand side. So when I want to add 1 right here, the only way to do this while maintaining the equality here, I could subtract 1 over here. If I add 1 and I minus 1, I'm really not doing anything to that left-hand side, or I'm sorry, the right-hand side, right? They cancel each other out. That's perfectly fine. As long as I do, I got to make sure if I'm adding 1 here, I'm going to subtract 1 right here. So it's the same line. They would cancel out. However, if I don't cancel them out, look at this cool little thing that I can do. This chunk right here is always going to be a perfect square trinomial. So I'm going to factor that like I normally would. So that is going to be, so if I just factor these first 3, factors the 1 that adds to be 2, in this case would just be 1 and 1. So I'd write it as x plus 1 squared. And then I just simplify these, a positive 3 and a negative 1, that's a positive 2. Isn't that a neat little trick? And we're almost done. The only thing I have to do now is distribute the number that I pulled out from the beginning, if there was one. If you get lucky and A was already 1, you'd be done at this step. But I'm not quite done, and this is where we got stuck a little bit yesterday. So I'm going to multiply negative 3 to that. So it looks like this. Negative 3 times x plus 1 squared minus 6. And now you're done. If we were to check this now, So remember yesterday I was encouraging you, hey, just throw in 0 and make sure you get the same thing. So if I plug in 0 here, I'd get -9, right? So I'd have 1 squared times -3 minus 6 is -9. Go back to the original. If you plug in 0, do you get out -9? Yeah, so that's going to help us check that we are doing this correctly. So definitely different than what I had told you to do yesterday. So I'm sorry 1,000 times. It was a long weekend. I goofed. But now we can fix it. And this is so much better. How do we feel about this? Okay, so on the back, there's some for us to try. So I'll walk you through another 1 or 2, and then I'll let you try some on your own. Okay, so the first thing we have to do is we have to factor out whatever A is. Okay, so let's pull that out. I'm going to switch to a pencil actually. So let's factor out A2. And then I like to leave a space right there. I mean, if you forget, it's no big deal. Half of 170 is what? 85?
Yeah.
Okay. So I leave a space on both sides of my constant just because I'm going to stick a number in there. What's the magic number I'm sticking in there? Careful now. Close. So this is B now, right? I want to take half of it and square it, just like I would if I was completing the square. What'd you say?
81.
Oh.
I said that like 5 times.
I did not hear you. I heard someone say 49 and then I heard 9. But 81 is correct. And so this is the part that's a little weird. You're going to add 81 here, but then you're going to subtract it here. Is everybody okay why I'm adding and subtracting like that? Yeah, I'm doing all of this on the right-hand side of the equation. So I can't just randomly add a number to one side and not add it to the other. So the only way to make sure that this is okay is to add it and subtract it from the same side. So they would cancel each other out if I was going to do it, but now I've set it up so I have that perfect square trinomial in the front. Okay, so now I go ahead and I factor those first 3 right there. That will always be that perfect square trinomial if we did it right. So what are factors of 81 that adds to be 18? It's a +9 and a +9, right? So we write it as x + 9 squared. And then these 2, I can just simplify those. That's just a +4. You with me so far? And now 1 step left. Let's just distribute that 2 and we'll be done. So you get 2 times x + 9 squared + 8. And so I guess I should ask you, now that you have it in this form, can you tell me what the vertex is? It would be at what, comma what? Evan? -9, 8. Right. It's always the opposite of that number, comma, whatever that one is. I'm just going to flip back to the other side and just add the vertex on the front too, just so we have it. What would the vertex of this one have been? Cedric, go ahead.
-1.
Yeah, -1, -6. Okay, because that's really what I want to be able to extract from this. Because today when we're graphing, if I have the equation in vertex form, I want to make sure that I can pull out from that where the vertex actually is. That'll make graphing infinitely easier. Okay, let's try the second one on the back. This time we get lucky and A is already 1. Okay, so I just don't have to factor anything out. I'm still going to set myself up pretty much the same way. I'm going to leave myself a little space around the constant. I want to figure out my magic number, which in this case would be, oh, someone said it. Cedric, 64 this time, right? So plus 64 and minus 64. And now you're set up to have that perfect square trinomial right there. And then what's that? 7? Okay, are we feeling better? Is this not so bad, maybe? Okay, you try number 3. Oh, I should have asked you where the vertex was. I keep forgetting. Vertex on this one would be at -8, 7, right? Okay, all right, go ahead. Try 3. You finish 3, go to 4. How did we do? Did you get what I got for 3? Where's my vertex? -7, -10. Take a moment, double check. If yours didn't match mine and you can't figure out why, let me know so I can help you. We feel like we can manage. Okay, try 4 and then maybe we'll jump to 6 because 6 is definitely a little bit different. Should we do 4 together or no? I'll give you a chance to do it without me butting in and just telling you what to do. You try. There is a fraction involved, but that's okay. Fractions are friends, not foes. Okay, so when you go to pull out that -6, it's fine here and it's fine here, but then you hit a 13. You can't divide 13 by 6 and get out an integer, but you can get a fraction out, right? So wouldn't I just have, let's see, it's a negative, so that would turn into a plus 13/6. Right? If I forced out a -6 there, you can always check yourself by redistributing it back in. -6x squared minus 12x, and then a -6 times 13/6. The 6 would cancel and I'd be left with that -13. Right? So I'm just dividing each A, B, and C by 6. So there I have it. And now I'm ready to do my funny little add subtract thing. What's my magic number this time? Jake?
1.
1, right? I want half of 2, which is 1, and 1 squared is 1. So I'm going to add 1, and I'm going to subtract 1. Just to make my life easier, instead of writing it as a 1, I'm going to write it as 6/6, just so I already have those common denominators. But realize I am just subtracting 1 there. And now I'm ready to go. -6, that would be an x plus 1 squared. And that's a, what is that? Positive 7/6. But look at this magic. When you distribute, and I do that last step, I get -6 times x plus 1 squared. And then what's this? When you do that times that, what do you get? What's -6 times 7/6? Jake? Just -7. Yes, Prince. Sure. Does that make sense? Isn't that neat? So sometimes even if there is a little bit of fraction action, don't worry, keep going. Keep going. So now you can tell me that this thing has a vertex where? Jake, go ahead.
-1.
Yeah, -1, -7. Okay. Let's jump to number 6. Because that one looks a little bit different. What do you think we should do first on number 6? Cedric? Yeah. As of right now, I turned this into standard form. This is a different form called intercept form, which we'll be talking about probably tomorrow. If not tomorrow, then the next day. But the easy thing for me to probably do is to just turn it into standard form. So if I FOIL that out, I'm going to get x squared plus 4 plus 5 is a plus 9x plus 20 on the end. And then I can just proceed like I have been. I'd pull out a common fact. Oh, I don't have to because A is 1. Sweet. I do run into a little bit of a snag because B is not even, but that doesn't mean I can't do it. It's just gonna have a little fraction. You know what? Fractions are all over the place, so don't shy away from them. You embrace them. So what's this magic number this time? Cedric?
81.
Yes, 81/4, right? Half of 9 is 9/2. Square it, you get 81/4. Add it there, minus it here. When you factor this chunk and get that perfect square trinomial, what is it? X what? What does this factor into? Jake?
The trinomial would be x plus 9 over 2.
Yes, remember, it's that we have that pattern. It's always half of that B term. Goes right there. And now I just have to do this math out. So if I times that by 4/4, that'd be 80 minus 81. So wouldn't it be a -1/4? Right? This does not have anything to distribute. So that's it. Your vertex here would be at what? Cedric, go ahead.
-9/2.
You got it. Isn't that something? Okay, so does this all make sense? We feel comfortable now converting between standard and vertex form? Okay, again, 10,000 times my apologies. I don't think I'll ever get over this, but I'll try. I will bribe you with munchkins. And lollipops. I still have so many. Maybe at the end. Huh? You like lollipops?
I'll just try.
Oh. You didn't say anything about lollipops?
Yeah, he said he likes
I like
lollipops.
Oh, yes. Me too. All right, so today we're gonna graph. You ready to graph? Probably your favorite thing to do in math is graph, right?
No.
Keep that function, yeah.
Oh, I love piecewise functions as well. So I'm going to start with this here. Let me give you this. And we're gonna see what we can do with this thing. Should we take a little break before we start?
Yes.
Okay, I think, let me just pause this. Please remind me when we get back that I have this paused.
Okay.
Okay, so let's take a look at the top one. So on your upcoming quiz test, I'm going to be asking you to find all of these things, as well as to graph the quadratic. So it doesn't really matter where you start. You might as well start by finding the vertex. You could do, if it's in standard form, you could do the negative b over 2a, and then you could take it and you could plug it in. But we have a better way now. We can rewrite this in vertex form, and then I can just look at the equation and know what it is. So take a moment and rewrite that into vertex form. I'm going to do mine down below so I have a little bit of room. Oh no, top off the orange, let's try again. What did you guys find the magic number to be? Yes. Did you get what I got?
Yeah.
Yeah, okay, cool. So now we actually have, oh, we have at least two of these answers. You can tell me what the vertex is now. Let me zoom in a little bit. Is that what everybody got? Okay, so where is the vertex? Yes, 5/4, comma, -9/8. So I've got that answer. 5/4, -9/8. I'm also going to plot that on my graph. So what is that? That's 1.25. And then -9/8 would be -1 and a little bit more. So my vertex is going to be right about there. There is also another one of these answers that you know right now without having to do any more math.
The axis.
Yes, the axis of symmetry, remember, is just the vertical line that goes through the vertex. So since I know where the vertex is, I can give the equation of that axis of symmetry. What is it? Jake?
X is equal to 5/4.
You got it. X is equal to 5/4. Now, I'm going to stress this. Your axis of symmetry has to be a line. You can't just write 5/4 on there because it's the line. X equals 5/4. So the axis of symmetry is the entire line, not just a number. So always make sure that that is in X equals whatever the X value of the vertex is. Okay, cool. So I have both of those. I guess you could kind of answer the domain and range right now too. The domain we can do. What's my domain going to be? All reals, right? It's a quadratic. I can plug in anything I want. So domain I can get. You can also kind of get the range if you know one other thing about this quadratic. Yeah, remember how to tell if a quadratic is facing up or facing down? Jake?
If A is positive or negative.
Exactly. Since A is positive, that means that this is going to be an, I call it up like a cup. So it's going to be an up like the cup graph, right? Which means that my vertex is the lowest point you'll ever get. Also known as a minimum, right? So if this is the lowest I'll ever get, that means the range has to be all the values that are bigger than this. So I would say Y has to be greater than or equal to -9/8. Does that make sense? Okay, so all of those things I can basically get just by finding the vertex. So now all I have left are to find the zeros and the y-intercept. Let's do the y-intercept because that's super easy. How do you find the y-intercept of anything? Jake, go ahead.
It's just B. Well, you know, the standard form then it would be the constant that's at the end. So B, but you could plug 0 in for X.
Yeah, you can always plug in 0 for X to find the y-intercept because at the y-intercept is an extra 0. Yeah, so take that original, pop in a 0 for X, and what comes out? 0, comma 2. That was easy. That's another point on my graph, 0, comma 2. Now, if you drew in your axis of symmetry, which I did not, but I will. Remember, it's always just that vertical line that runs right through your vertex. And it's called an axis of symmetry because everything is symmetrical around it. So you could take this and reflect it to the other side. It's a little bit tough when they're not like perfect points, but that was 1 1/4. So if I go 1/4 and 1 more, I'd be right there. Now, the only thing I have left to do is to find the zeros. I can estimate based on my graph. I know they're going to be, if I just kind of, I know it's going to be somewhere in between 0 and 1. And this one's going to be, it looks like it's close to 2, but I don't know for sure. How would I find, without just kind of guessing on my graph, how do you find it algebraically? How do you find the zeros? Go ahead, Jake.
You plug 0 into the line vector.
Exactly.
Vector form.
So to find the zeros, I'm going to do that down here also because I need a little bit of room. You're just going to solve this, right? plug in the 0 for y, and let's solve this thing. 2x squared minus 5x plus 2. So you could see if it factors. If it doesn't factor, you could do completing the square or a quadratic formula if you wanted, but I think this one does factor. Right? I'm going to try slide and divide. Right, yeah, so I slid. Did my slide, now I'll divide. Did you get what I got? So the only thing that I have left is to sort of fancy up my graph. Make sure I have all the points in that I am sure of. So now I know that my x-intercepts, one of them's at 1/2, which makes sense. And then the other one's going to be at exactly 2. So I'm gonna just make my graph so nice and neat. Remember, parabolas are supposed to be a smooth curve, so you don't want a sharp corner there. I kind of made it a little sharper than I meant to. And there it is. It has all the pieces that I want. I double checked that everything fits. Yeah, got my zeros right, my y-intercept, axis of symmetry. Yep. If you want to hold off on the range until you have the graph, sometimes it's easier to see it when you like literally have the graph in front of you. Now, if you look at the bottom, even easier. Before I move on, does anybody have any questions about this one on the top? No, we're okay. Okay, look at the bottom one. The bottom one is already in vertex form. So you already know a whole bunch of answers. Start with the vertex. What is it? -2, 3. All right, -2, 3. So I know my axis of symmetry. X equals what? Say it louder. -2 is right. It's always just whatever the x coordinate of your vertex is. That's all. Domain, it's a quadratic, so you know the domain is always going to be reals. Let's do the range after we get the graph done, I guess. Zeros. So I'm going to have to solve this. So, let's go ahead. I'm going to do the same thing, right? I want to just replace y with a 0, and let's see where we can go with this thing. I have -2 x plus 2 squared plus 3. So what do you think you want to do? You have some options. What would you do? Anybody have a thought? So you could. You want to turn it into standard form? You can. That is one option, and it's a viable option, right? You could totally do that. Or go ahead.
You could substitute y for the x plus 2. Like y plus 2 equals. I mean x plus 2 equals y, and then put like -2 y squared.
Why would you do that? Oh, I think you're confusing like factoring something in a quadratic pattern. Yeah, that's not quite what you want here. Evan? Yeah, let's get the thing being squared by itself. So we can subtract 3 from both sides. And then I'd have to divide both sides by that -2. So now I'm going to move over here because I'm running out of room. So now I have 3/2 equals x plus 2 squared. And then what? Jake,
You got square root of both sides.
you can take the square root of both sides. Don't forget, whenever you take a square root, you need to remember positive and negative roots. So I have positive negative square root of 3/2 equals x plus 2. Now, since I'm, oh man. So I'm gonna want the zeros. When I actually graph it, like I want them in decimal form, right? Because I'm never gonna know where to put like 2 plus √3 on the graph without turning into a decimal. However, when you're giving the zeros, I don't want just a decimal. So let's go ahead and rationalize this, and then we just subtract the 2 over, and we'll have at least that answer. So I'm just gonna do my work over on the side. If you have the square root of 3 over the square root of 2, and I want to rationalize that, I multiply by what? Jacob?
Radical 2.
Yeah, radical 2 over radical 2. So that gets me a radical 6 over 2. So that's the same thing as this, just with the rational denominator. So now I'm here. I have positive negative √6 over 2 equals x plus 2. So then if I just subtract that 2 over, this is where I end up. -2 plus minus √6 over 2. So there are my x-intercepts, which means a whole lot of baloney when I go to graph it, because who knows where those things are. I'd have to grab my calculator and ask it what it is as a decimal. So my zeros, though, I've got them. -2 plus and minus √6 over 2. Can I simplify the -2 what?
Do you simplify the -2 because over A2?
No, it's not over 2.
Oh, yeah. Yeah, I wrote mine wrong. I wrote mine over.
Oh, okay.
Yeah.
So when I'm going to make this on my graph, if I wanted to plot where those were, I would just grab my calculator and ask it what -2 plus √6 over 2 is. And one of them is at -0.77. So right about there. And then the other one, let me just change that to a minus. I'm going to do it with the six divided by 2. One extra. There we go. -3.22. 1, 2, 3.22. Right about there. Okay. And so, I mean, I have enough to kind of connect these. Where's my y-intercept going to be? How do you find that again? A y-intercept? Yes, I just replaced x with the 0, so that should be easy enough. 2 squared is 4 times -2 is a -8 plus 5, or plus 3 is a -5. 1, 2, 3, 4, 5. So that lines up pretty well. Got a nice looking parabola here. Oops, until I want to mess it up. There we are. What a nice parabola. So that was at 0, -5, we said. So now the range is hopefully easy to see because you see it in the graph. The range would be, Jake?
Y is less than or equal to 3.
Correct. Less than or equal to 3 this time, because my graph is going down. Such an easy check, by the way. Before we even started, I should have asked you, hey, what do you know about this parabola just by looking at the value of A? If A is negative, you know it's got to be down like a frown. So if you graph this whole graph and it's up like a cup, that's a problem. You know it's not right. Thoughts? I know most of this, I know you've found all these things before, so hopefully it's not too bad. I'm going to give you some to try on your own, and that's it. That's it. That's not so bad, right? No. All right. Let me set this aside. I will stop the video in a second. We are not going to do all of these, so let me give this to you, and then I will tell you which ones we're going to look at today.